So in the first video I explained the difference between exponent form and radical form and some common things that we do with exponent form and radical form. The one thing I didn't mention in the last video is when we see this rational exponent, we know we talked about the root. The roots grow under the ground, so anytime you see a number underneath the fraction symbol, fraction bar, we know that that is the number that we put in the root position because roots grow under the ground. And another way to remember that well, I just realized this, that P and R are integers, and P stands for power and R stands for root. That's a great way to remember. P stands for power. Well, the power is going to be the number that we put right there. That's the power. So P stands for power, and that's why it's written there. P stands for power. But the one thing I was going to say is that flower rhymes with power. We say flower power. Flowers grow above the ground. So flowers grow above the ground, roots grow under the ground, and therefore we have flower power. Powers are up here, roots are right there. And let me circle that root right there as well. So, oops, I thought I had the red. My bad. So there we go. And we have roots there. So let's just go ahead and do a few examples, and you can rewind if I'm going too fast, but that's the beauty of video. 64 to the 1/2, we're supposed to simplify that. And if we write that in radical form, we write that as the square root of 64, and the square root of 64 we know is 8. So that's it. 64 to the 1/2 is 8. 36 to the 1/2 is 6. So when you get good at this, when you realize, oh, to the 1/2 is square root of 25, you don't have to even show any work. You can just simplify. All right, so then for number 2, we have 16 to the 3/4. Again, we have an option now. That's the root. So we have the 4th root of 16 cubed. And if you know what 16 cubed is, and then take that big number and know what the 4th root of that number is, that's great. But I would prefer to not even have to think that hard and just find the 4th root of 16 first and then raise that number to the 3rd power, because I know that the 4th root of 16 is 2, and then I can raise 2 to the 3rd power, and I'm going to go ahead and get 8. So I don't have to make the numbers big. I really would rather keep the numbers as small as possible. And then for number 3, we see we have 25 to a negative power. So let's immediately write that as a positive exponent, and then we can deal with what's underneath what's in the denominator here. And we have 25 to the 3/2, and I'm going to go ahead and I'm already going to know that I'm going to find the radical 25. I don't have to put the 2 there if I don't want to, because I know that a 2 there means the square root, and I already know without a 2 it also means the square root. So the square root of 25 is 5, and we know that 5 cubed is like 5 times 5 times 5, so that's like taking 25 and multiplying that by 5, and it's like having 5 quarters, and 5 quarters would add up to $1.25, so 5 times 5 times 5 is 125. We can go ahead and see how much we can get done in the next video. I like to keep the videos between 5 and 6 minutes. So in this next example, number 4, pause the video if you don't have that yet. But for number 4, we see we have a negative number. No matter what, that negative is going to stay outside the radical. It's not negative 9 all to the 3/2. It's the opposite of 9 to the 3/2. And so that means that we have the opposite of the square root of 9. Now this time I'm not going to write that 2 right there because I already know that's the root, square root, so it's just going to be written like that. I'm going to raise that to the 3rd power, and therefore, keeping that minus sign along for the ride, we have the square root of 9, and the square root of 9 is 3, and 3 gets raised to the 3rd power, and we have 3 to the 3rd power is 27. So that minus sign is on the outside of this whole thing. So keeping in mind, when you see a minus sign, unless it's like negative 9 to the 3/2, it's not. Unless it's got parentheses around the negative 9, then you have to keep that minus sign just coming along for the ride, like I said. And then for the next one, I guess we can get one more in before we go to the next video. 27 to the 4th power raised to the negative 1/12th power. So that could seem a little daunting, but we know that when we have power to a power, a to the m raised to the nth power, we just multiply the power. So you've already learned that. And so we're going to write that as 27 to the 4 times negative 1/12. Well, 4 times negative 1/12 is negative 4/12, and negative 4/12 is negative 1/3. So notice that I didn't change the base at all. All I'm doing is manipulating the exponents and rewriting it in such a way that it makes it easier. Now I can go ahead and write that negative exponent as a positive exponent, and I move that down to the denominator. We know that any number to a negative exponent can be written as 1 over that number to the positive exponent. And then we know that 27 to the 1/3 is the cube root of 27. And we should know, that could be one of our kind of quick ones that we know. The cube root of 27 is 3. So we have that entire kind of big ugly expression right there has a value of 1/3.